Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P2122 indicates a specific issue with the Accelerator Pedal Position APP Sensor A circuit. This error typically presents a problem of low voltage within the APP sensor circuit, which is crucial for engine management and performance. The APP sensor is designed to measure the angle of the accelerator pedal and relay this information to the engine control module, ECM, which then adjusts the throttle response accordingly. The APP sensor is usually located on the accelerator pedal assembly. It consists of multiple resistive components, and when these fail or operate below threshold levels, the DTC is triggered. Before starting the troubleshooting steps, it's important to record any freeze-frame data and onboard snapshots for accurate diagnostics. DTC P2122 arises when the APP sensor A circuit experiences low voltage conditions. The APP sensor plays a pivotal role in measuring the position of the accelerator pedal and communicates this data to the powertrain control module, PCM. If the voltage received falls below a specified threshold, generally less than 0.2 volts, the PCM recognizes this fault as a DTC. Typically, the APP sensor is situated on the accelerator pedal assembly, integrating into a multi-sensor platform that contains other essential components. The failure of this sensor can hinder engine performance, affecting throttle response, which can impact overall driving safety. The potential causes for DTC P2122 primarily include poor electrical connections and loose terminals associated with the APP sensor and PCM. These issues can lead to intermittent or complete voltage loss across the circuit. Another common reason is damaged wiring within the harness connected to the APP sensor. Frayed or broken wires can lead to low voltage readings. Additionally, the APP sensor itself may have failed, either due to internal faults or environmental factors. Each of these issues can contribute to the DTC triggering and must be ruled out during the diagnostic process. Symptoms associated with DTC P2122 can include poor throttle response, where the vehicle hesitates or lacks the expected acceleration when the pedal is pressed. In more severe cases, the engine might stall unexpectedly, particularly during deceleration or idle. A check engine light will typically illuminate on the dashboard to signify engine management issues occurring due to the sensor failure. This problem may also lead to reduced engine power, felt as lag or less responsiveness in acceleration. Each of these symptoms can create safety hazards when driving, making it crucial to diagnose and rectify the underlying issue immediately. The first step in troubleshooting DTC P2122 involves turning the ignition switch to the on-to position, allowing systems to activate without starting the engine. Utilizing the Honda Diagnostic System, HDS, check the parameters of the APP sensor A to determine if the voltage values fall below the threshold of 0.2 volts, as noted in the diagnostic information. If the current conditions match this threshold, the fault is confirmed, and you will proceed to the next step. However, if the APP sensor voltage readings are nominal, it may indicate an intermittent fault. In such cases, it is crucial to check for poor connections or loose terminals at both the APP sensor and PCM as part of further investigation. Once the initial testing is complete, turn the ignition switch to lock 0 to ensure all systems are powered down safely. Disconnect the APP sensor 6P connector, which is crucial for isolating the sensor from the vehicle's system. With the sensor disconnected, turn the ignition switch back to the on-to position. Then measure the voltage between test points designated as VCC4 and SG4. The specific test points are defined as APP sensor 6P connector number 4 brown, and number 5, light blue. If the measurement indicates about 5.0 volts, proceed to the next troubleshooting step, which involves a check of the wiring, primarily focusing on the APS1 line. However, if the voltage is not as expected, it necessitates further investigation into wiring integrity and connections. After confirming voltage levels, turn the ignition switch to lock 0 to avoid any accidental activation of vehicle systems. At this point, employ the HDS to jump the SCS line, effectively shorting it for troubleshooting purposes. Disconnect the PCM connector A, 49P, to isolate the PCM from the circuit. Subsequently, check for continuity between the test points established within the APP sensor and the PCM. Test point 1 should correspond to APP sensor 6P connector number 6, orange, while test point 2 should be connected to the body ground. If there is continuity, it confirms a short in the APS1 wire, likely leading back to the PCM, necessitating repairs. If not, proceed to the next troubleshooting step to check for open circuits in the APS1 wire. In this step, connect terminals A and B with a jumper wire. Terminal A will link to app sensor 6P connector number 6, orange, while terminal B connects to the body ground. Ensure all connections are secure. Following the jumper setup, check for continuity between the points outlined. Test point 1 should be the PCM connector A, 49P number 28, orange, and test point 2 leads back to body ground. The conditions for continuity should reflect IG lock 0. If continuity is confirmed, the APS1 wire is functional, and you should proceed to further checks in the system. However, if there is no continuity, this indicates an open wire in the circuit, which needs repairing before re-evaluating the entire system. Following the resolution of any wiring issues, reconnect the PCM connector A, 49P, securely. Then connect terminals A and B with a jumper wire. Terminal A correlating to APP sensor 6P connector number 4, brown, and terminal B correlating to APP sensor number 6, orange. This jumper is critical for checking conditions when the ignition is turned on. 2. Monitor the APP sensor parameters via the HDS to confirm whether it remains under 0.2 volts. If it does, there is a need to proceed with updating the PCM software if it isn't current, or replace the PCM with another known good unit before conducting repair verification. Alternatively, if values are back in normal range, replacing the APP sensor may be required to fully resolve DTC P2122. In this step, revert the ignition switch to lock 0 to ensure no processes are inadvertently triggered while disconnecting parts. As before, short the SCS line using the HDS. Disconnect the PCM connector A, 49P, isolating it from the circuit completely. Proceed to create a bridge with a jumper wire connecting terminals A and B. Terminal A will be connected to APP sensor 6P, connector number 4, brown, while terminal B connects to body ground. Check for continuity between VCC4 voltage supply points, ensuring that the test conditions match those outlined in the diagnostics. If continuity is confirmed, it indicates proper function of the VCC4 wire, allowing for software update or PCM substitution, and completing repair verification. Otherwise, repair any open wiring faults identified. The final stage of repair verification entails turning the ignition switch back to lock 0 for safety. Ensure all connectors are securely reconnected in their appropriate locations to maintain system integrity. Following this, reset the PCM using the HDS approach, which clears any stored fault codes and resets operational parameters. Conduct the PCM idle learn procedure to enable the system adapting to any changes made during the troubleshooting and repair processes. Finally, check for any pending or confirmed DTCs with the HDS to ascertain if the P2122 DTC reappears. If the code persists, this may indicate deeper issues that necessitate re-evaluating previous diagnostic steps and findings. Preventive maintenance is critical in avoiding future occurrences of DTC P2122. Regularly inspecting the wiring connections related to the APP sensor can help identify minor issues before they develop into major faults. Always check the physical integrity of the APP sensor connections, ensuring they are clean with no corrosion or damage. Additionally, keeping the PCM software updated can eliminate operational bugs and improve overall vehicle performance. These proactive measures can significantly reduce the likelihood of encountering similar DTCs and promote the longevity of the vehicle's electronic systems. DTC P2122 is a clear indicator of issues within the APP sensor A circuit, most notably low-voltage conditions affecting performance. By following a detailed step-by-step troubleshooting guide, potential causes such as poor connections and damaged wiring can be effectively identified and rectified. The process emphasizes the importance of employing proper diagnostic tools, such as the HDS, ensuring precise readings and operational assessments of all components involved. Furthermore, implementing preventive maintenance practices can promote long-term reliability and avert future problems within this critical system. Engaging in these best practices ensures high performance and safety for drivers and passengers alike. Please like and subscribe to the channel. See you next time!